Welcome to Lab 2, Lines of Charge. The purpose of this lab was to take the data collected in the previous charge tapes experiment and model them computationally as a line of charges. We then compared the line model to the point charge model. This was done by dividing the tape into several segments and treating each part as an individual point charge. GlowScript was used to model the tape and relevant forces. As a preview of the results, the point charge model showed that the charge on each tape was 1.17 E-8 coulombs, and the line of charge model showed the charge on each tape to be 2.4 E-8 coulombs. Relevant theory for this experiment includes Newton's second law, which is also known as the momentum principle, which states that a change in momentum is proportional to the net force felt by a system. Coulomb's law, which describes attractive or repulsive forces between charges based on the amount of charge and relative position between the charges. This law can be used to determine electric field resulting from a charge. The universal law of gravitation, which describes attraction between two masses based on relative position. This is also where we get our gravitational constant, g, which is negative 9.8 meters per second. That's acceleration due to gravity. And the concept of superposition, which means that electric fields do not affect one another but do influence the net field. Therefore, multiple point charges will all be considered in the net electric field. And here's a little diagram showing a net electric field, the direction of a positive and negative point charge. From Lab 1, our initial conditions were a distance between the tapes of 0.04 meters, tape mass of 2 E-4 kilograms, tape length of 0.2 meters, tape width of 0.02 meters, and we have our tape area, atom area, and previously we found the number of atoms in each tape to be 4 E17 atoms. In Lab 1, we can recall that the system was the bottom tape, and the surroundings were the ruler, earth, our hands, the top tape, and everything else. And then the distance between the charged tapes was 4 centimeters. And our results were that our electric charge was 1.17 times 10 to the negative 8 coulombs. But that was if we treated the tape as a point charge. In reality, it's not. So here we calculated the new electric charge using the formula seen here for the field of a line of charges. We isolated Q to get 2.4 times 10 to the negative 8 coulombs. So our gravitational force and electric force stayed the same between the two labs. However, we got a larger electric charge per tape. And here you can see R in this formula is the distance between tapes and L is the length of the tape. Moving on to our computational model, this section contains constants such as Ke, which is 1 over 4 pi epsilon naught, or 9E9, gravity, mass, charge, which we found in our actual experiment, seen here, length and distance of those tapes. These were our functions. So this calculation loops here calculate our electric field and line of charge for each tape. So this section here is field, and you can see that we use our formula for field. And this section creates that line of charges. This section here uses the concept of superposition to add together all the electric fields from those point charges, because each of the previous electric field calculations was based on a point charge. However, here we're taking all of those to create a net field. And for a grand finality, here was the results of our computational model. You can see here that the magnitude of the electric and gravitational forces aren't exactly the same, but they are pretty close. So here the green represents our electric field from each individual little point charge that we created. The white is the electric force going this way. The yellow is gravitational force. This red tape, which you can't really see here, but it's right here, is our top tape, and blue is the bottom tape. For this lab, we assumed negligible air resistance and friction. We also assumed that each tape had the same amount of charge and uniformly distributed charge. Sources of error could have been errors in precision of our measurements or loss of charge to the environment. What if we compared the Lab 1 and Lab 2 results? Well, Lab 1, we found that our point charge, each tape had 1.17 E-8 coulombs, whereas the line of charge model showed 2.4 E-8 coulombs. But which is more accurate? Well, these values differ due to precision, like the amount of precision in the estimation. It's the same concept of like integrals versus Riemann sums. The more different segments you have, the more accurate. But this means that the line model is more accurate since it takes into consideration several points instead of just one.